Okay, Ken. So I think good afternoon. Thanks for having me here to share on our problem statement. So I think this is just a disclaimer. The presentation is prepared by Citrum, and don't just rely on this to make your own. I mean, just it's not. Try to keep it within confidential. Yep. And a lot of this, I think first I would like to thank Yes Enterprise Singapore, Padang and Co. for setting this platform for us to share our problem statement, to look at startups that can really help us to push what we are doing internally. And I think just to start off with a brief introduction of Citrum. So I think at Citrum, today we are a premier global player. We provide the engineering solution in both, offshore marine as well as the energy industry. So today, a lot of the product that we do, besides the conventional oil, gas related jackups, semi-submersible, the FPSO play, today we are also moving into the energy infrastructure. And these are all revolving around the marine space, offshore space, which means that they are typically submerged uh, or they are floating, in the water. So to touch on more about our global footprint and product suite, so basically, HQ is in Singapore, but we do have a global footprint across the globe as a global delivery model to serve our client. So whether is it in US, in the Gulf, or is it in Middle East, we do have our footprint, and we continue to provide the needs in the marine offshore and energy space. So here are some of our examples of the product suites that we have, from floaters to jackups to even repair and upgrades. These are all the work that we have done. So besides shipyards, we do have engineering center, technology center. I think so today when we put forth this problem statement, it is very much from the digital space as well as the technology center space that we want to use a different lens to look at what we can value add in the product that we offer. So in terms of the problem statement, the way we have crafted is that we are looking at sustainable, non-toxic, anti-fouling, corrosion mitigation solutions. This is actually on the backdrop that, while we have been in this marine offshore industry for many decades, we have been going into solutions like anti-fouling anodes, paint coating on all these offshore structures. And we know that, these are the structures that are prone to corrosion. There is a regime, there's a routine to go for all the necessary survey according to the classification societies and so forth. So that is the norm of what is being prescribed today in the market. And why do we put this up uh, as a problem statement since there is a solution? So what we are pushing the boundaries here is that first, when we want to extend the service life of all these offshore floating structures, particularly wind or even conventional oil gas, I think one of the key questions is to look into things around sensorization, looking around structural health monitoring. And the other spectrum that we would like to focus more on in terms of the structural health is the sustainability aspect. Because when we talk about paint coatings, anti-fouling, these are all sacrificial and it affects the marine biodiversity. So why we crafted the problem statement in this manner is also to kind of focus more into the nature-based solution aspect, coexistence with marine biodiversity. So this is something that it is aligned with our sustainability goal to be more sustainable in the product suite that we provide. So at this juncture, while we understand that structural health monitoring, to look at structure integrity and so forth is something that we also welcome, but in all the push in terms of the boundaries for solutions, we would really want to see if there's any creative solutions that can coexist with the marine biodiversity that is from a nature-based aspect. So this is also particularly important because every time when we start a marine offshore project these days, there is a need to do all the environmental impact assessment and so forth. So with in mind that if a nature-based solutions or a coexistence with marine biodiversity will work for such offshore or floating structures, Then at the very onset of the project in the EIA part, then we can start to also surface and reduce some of this impact. So this is kind of like a backdrop on what we are thinking when we craft out this problem statement. So I'll dive into more on the technical requirements to clarify. So first thing, I think basically the key important thing of the solution, it has to prevent corrosion biofouling. So there are known solutions, so we need to look at differentiators, and this is particularly important for those that we have submerged surface or critical load bearing components. And one of the key thing is we want to, technically, if we go for the nature or bio-based kind, we want to make sure it is biodiversity friendly. And the other question is it has to demonstrate the durability and the robustness for long-term submerged condition. So I think these are very prone to harsh environment operating, and the cost of maintenance and all this will be actually quite challenging as well. And we want to apply these to primary structures. So that will be things like whether is it monopile, jacket, substation, floating platforms. These are some of the products that we actually does as an EPC, and this will be something that we are looking at to explore and put it into part of our solution offering. Yeah. And the other part is to integrate with existing maintenance inspection framework. So what we are looking at is, first, we are looking at the feasibility of the solution. Next, once we ascertain the feasibility of the solution, it is to shrink it up with a series of maintenance and inspection framework and workflow. This is the part where the true value comes, is when this solution can be accepted and it becomes a value add to enable reduction in survey requirements and so forth, which will be something that we have to take through as part of some joint development program, going through verification and validation with the necessary class society. So this is something that we look for to ensure that, besides the technical solutions or the nature-based solutions, it will also be qualified in a way that it forms part of the regime in terms of inspection to really value add to the life cycle management of the structures. There may be some data, as if there is a need, we can provide certain data sets in certain sea state or condition where Seatrum has assets that is operating, and basically the solution has to operate effectively in marine conditions. So it really depends on whether the startup is looking at a more sensorization based kind of solution from the monitoring perspective, or really a true blue kind of nature based solution to link onto the structure and make it coexist with the marine biodiversity. So this is probably the technical requirement that I just put forth as some of the guide. Then in terms of performance, it is really to look at the reduction in the fouling. I think one key important thing is it should maintain or at least preserve the structural integrity. So the last thing is that it actually weakens and ended up bring forward the maintenance or the repair requirement. And we will have to work out some quantifiable savings. So this is something that it might not be something that is very visible from onset, but we probably have to work together to see how we can quantify some of this. And that is why I bring in the environmental impact assessment as a leading kind of approach, because very often certain development work will require us to have some cost involved to relocate certain biodiversity lives and so forth before the development can goes on. So that is where, if the solution can coexist or reduce the impact, then that is where we can work together to see how much we can quantify on some of these savings. Then the environmental performance, yeah, and I think lastly here is really talk about a biodiversity positive design. So this is the part where nature-based or sensorization-based, we will both access them. But I think nature-based is something that is very new and niche. It might sound very, I would say that not as known in today's context, but I think marine biodiversity is something that is upcoming in the sustainability field, and we do recognize there is a lot that we need to push in order to really preserve all this. Yeah. So I think this is just a short flyby on what I have. I'll probably pause here to take the questions. Yeah.
Thanks, Ting Ho. Folks, if you've got questions for Ting Ho, please type in your questions in the chat box. Just hold for a moment. Maybe whilst we're waiting, just very quick question on examples of the most challenging areas where the offshore structures where corrosion or the biofouling tends to accumulate. Can you just elaborate a little bit on that?
Okay, so basically, I think today in the offshore structure, the 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 corrosion typically happens in the submerged part, and but what is something that is of focus are all the primary structures of the, whether is it a platform, or whether is it a jackup or semi. So generally in the primary structure, there is quite extensive regime. Like every 5 years or every a special periodical survey, there is a need for them to bring the structures or the platform back to shipyard for assessment. And for those fixed structures that are submerged, then they need to do certain underwater survey. So that is kind of the norm that is happening in the market today. And I think we know that, we have done a few structural health monitoring, advanced warning for corrosion. So that is really riding on the digitalization, the sensorization, and the technology wave. But what we are trying to push further here is that while we deploy these are still kind of uh, uh, these are monitoring systems. But what exactly coming from the other aspect is that if we can turn it around to say that the structure forms part of the landscape, the structure forms a cohesive environment with the marine biodiversity. That is kind of the landscaping aspect of it. And this is something that we would like to also open this up as a challenge. Coming from an EPC engineering field, we know there were a lot of numbers to crunch, structural integrity. We know these details. So there isn't really a ready solution in the market today on this aspect. So while we also open up to structural health monitoring kind of solution to preserve the integrity and reduce the fouling, but we also want to really push the nature aspect of this.
Thank you
Thanks, Henry.
for
Yeah.
very detailed response. And there is a question here, and I get you to respond to that. Is structural health monitoring to give advance warning of corrosion a topic of interest or only mitigation?
I think we welcome both. So, structural health monitoring, so long as I think we have to look at. I think the key challenge today with structural health monitoring, we will be looking at things like the kind of sensorization that needs to be deployed. So, very often, if this is inbuilt from initial design onset, they will have been built in when it is constructed. But there's also another aspect that there is already a lot of structure in operation out there today. And if it is structural health methods that we have looked into that we can actually retrofit, then that will be something that we are open to also assess. As for what methods have been tested already, I don't think I don't think I'm in the position to share more detail on that at this juncture. Yeah, but we will welcome any proposed SHM, then we will look at it.